I'm honored to introduce our final year project. It is titled Quadcopter under the supervision of two professors. So I am sure you would like to know what a quadcopter is. A quadcopter is a four-rotor helicopter with a cross-shaped frame. Unlike a traditional helicopter, which usually has one main rotor in the middle to produce lift and one small tail rotor to counteract the torque. The quadcopter has four rotors of the same size. So this is our overall design. As you all know, an unmanned vehicle can be used in aerial photography, can be used in detection device, or can be used in perimeters such in rescue missions. Based on this motivation, we would like to build a quadcopter from scratch, which can take off and land safely and gently in the confined space. It must also hover steadily. It can also receive commands from a user from a mobile device or a radio controller. On top of that, it can shoot panoramic landscape. So based on these objectives, we design our quadcopter with four features. First of all, it is the overall block diagram. On top, you can see that is the ground station, which is controlled by a phone, and using the Bluetooth as a link to the quadcopter, we can easily approach the quadcopter electronics hardware. But to have a quadcopter fly, at first we need to have an airframe. So this is our overall design for the airframe. On top we have electronics, in the middle we have battery, and below is a camera. Especially we have the crash prevention landing gear, which is not seen in any design. This is our overall design from SolidWorks. And the middle of the quadcopter is the weakest part of the quadcopter. So we need to strengthen it by double gusset joint, as you see in this picture. After that, we manufacture. The special thing about this quadcopter is that we handcraft the whole airframe, and this is when it's done. So next, I would like to talk about the electronics hardware. We use Arduino Mega as a microcontroller. What is special about our electronics hardware? It is a proportional integral derivative control loop. Different from existing model, our quadcopter has two PID control. First is from the design angle from the users. We get the angle PID to put in angular speed PID. This design angles angular speed with the measure angular speed. This measure angular speed is important because it measures the wind speed. For example, we can have a very balanced quadcopter, and let's look at how we tested it. Uh, last, Lastly, I would like to talk about the company's software. We choose Android for our mobile device software, and for installation of the software, there's no need to install because we only need to load the program on an Android device for the first time, and it can be run independently for later times. This program on the left is the program on the screen, and on the right is the quadcopter which is not ready. When we turn on the quadcopter, there is a trace of the Bluetooth from the quadcopter, and after that we need to press the connect to connect to the Bluetooth, and after pressing connect to the Bluetooth, there's calibration, gyroscope, accelerometers, and the PID controller, and also the motors on the motors and the receiver module. So press on orientation. So you can see there are four parameters: yaw, pitch, roll, and throttle. So this how it's done. The throttle coming up is flying up, and we move it forward a bit. We move back. That means it's will steady, and the yaw rotation to the left. And when the throttle came down, it came down. In the conclusion, this is a multidisciplinary project with three different majors: mechanical engineering, electronics engineering, and computer science engineering. As a conclusion, I would like to show a video